All right, this is the pretest. I'm going to go over the multiple choice questions in the back there. Question number 1, determine the product of h of x of the given linear and quadratic factors. Product means to multiply, so you're going to take f of x times g of x. So you have here a linear because it's power of 1, and this is quadratic factors. That's a power of 2, so basically you're going to multiply those. So you're going to use your box, 4x times -1, and negative 3x squared minus 2x plus 5. Remember those additions and subtractions, make sure you keep that by the term itself. So 4x times negative 3x squared is negative 12x cubed. 4x times negative 2x is negative 8x squared. 4x times 5 is 20x. Negative 3x squared times negative 1 is positive 3x squared. Negative 2x times a negative 1 is positive 2x. Negative 1 times 5 is negative 5. And then I'm just going to combine like terms. The nice thing is if it's never missing a term here in descending order, the diagonals apply in the box method. So negative 12x to the third, negative 8 and a positive 3 gives me a negative 5x squared. 2x plus 20x gives me 22x, and then the negative 5, your answer is A. I believe we went over question number 2 in class. There's another video on that, but to elaborate, you can also show that function s of x, if it's linear or quadratic based on the first common difference in this case. So I can definitely tell it's going up by 4. So this is a first common difference. This would be linear. And then you can kind of tell this is quadratic because it's symmetrical about 2. And the numbers kind of repeat 7, 7, 22, 22. So you'll see a second common difference. So linear times a quadratic gives you a cubic function. Question number 3. Which is a characteristic of all cubic functions? So basically you think of it as true and false. And when I think of false, I want to draw a picture and understand why it's false and not true. They're basically saying all cubic functions are increasing. False, here's my counter example. This is a cubic function here, and it's actually decreasing. So get those all in the same window. B, they have at least one x-intercept, and I put true because a cubic function is an odd degree polynomial, and so is linear. And linear must go through the x-axis, so that means that all odd degrees must go through the x-axis at least once. So that means one x-intercept. That's true. C, they have exactly 2 relative extremas, and my answer is false. Here is y equals x to the third. It is the parent function of the cubic function. Notice how there is no maximum or minimum. That's what an extrema means. So it has 0, so that's false. Remember, the word is all. And then D, they are symmetrical about the origin. So here's my counter example. About the origin means here in quadrant 3 and quadrant 1 have to be exactly the same. And that's not that the case. And you can also see that in quadrants 2 and 4. And then the last question, question number 4. Let's see if I can get that in here. Which is a possible number of extrema for a 5th degree polynomial? So a 5th degree polynomial, you're thinking starts down, ends up, give you some basic shape. You can look up here as 1, right? As an example, could be. But here it says the possible number of extrema. Well, there's an equation for the extrema. Extrema equals to the degree minus 1. So if our degree is 5, 5 minus 1 is 4. So we can have 4 extremas. There's a maximum of extremas is 4 for a polynomial with a degree of 5. But you're asking, what is a possible number based off of this list?